Hi, hello, namaste. Welcome to Parthas tutorial, and I'm Madhavi. As you know, in this Parthas tutorial channel, I'm explaining the topics which are about the physics related topics only. I'm explaining here, and some of the videos I'm explaining IIT, JEE, and the related topics also I'm explaining, and one of the TS state syllabus also I'm trying to explain to you. And recently I have started the 10th class first lesson, that which is a reflection of light in a curved surfaces, which is the first lesson of a physical science. Okay, for the Telangana state. Maybe it is also there for the Andhra Pradesh AP state also, which is also there in the CBSE syllabus, which is useful for all, not only for a respective class. Okay, so we'll see in the, as of the, I'm sharing this entire lesson not in a completely one video, as not as a lengthy video. I'm explaining as a part wise. So as of now I have explained up to 8 to 9 parts in the same topic only, same lesson only. So in the previous video we have discussed, I have explained some problematic questions which are related to the focal length. Suppose if you are giving focal length and object distance, how to find out image distance, and if you know the magnification, and how can we predict the characteristic of image, which means what type of image can be formed. We can also predict if we have a magnification, and if we know the u and f, or if we know the v and f, any two values, we can completely get a details, we can completely get a details by the calculation of the formulas with using the given formulas which I already explained to you. So now see, so in the previous video and that previous video I have said you about the sign convention, mostly from starting onwards, reflection and how the ray diagrams will be reflect, which means in the case of the concave convex mirror, how the light rays will be behave, and how many types of rays will be passed, those only ray diagram. And image formations also we have seen, at which point we can able to see the proper image, at which point we cannot see the image. So that all the things we have seen in the case of image formation. And thereafter the two formulas I have explained, sign conventions, which is very important question. So and also you have to analyze, you have to get you have to remember the sign conventions compulsory, at least to solve the problems also. Yes, so that's the reason I am telling you sign convention is very important. And thereafter I have explained the three formulas, that again I am telling three. Why? Because one is a focal length formula, or else radius of curvature formula, which is relation between the r and m. Yes, next formula is a mirror formula, 1 by f equal to that. And third formula is a magnification formula. I have explained these three in the previous videos. If you didn't watch those videos, I'm giving the channel link to you in the description box. You can please go through and watch the videos, and you will be get clarity about all those. And I have also explained them with the problematic questions also, I have explained to you in the case of the concave. And we'll see in the convex mirror. And the convex mirror, we already know convex mirror is a diverging mirror. So wherever diverging, the light rays will be diverged, reflected rays will be diverged back. So those may not intersect each other. So if those are intersecting, then only image will be formed now. Even it is a plane, even it is a concave, even it is a convex, compulsory the reflected rays should be intersect. If there is no intersection will be takes place between a reflected rays in the case of the mirror, then what we have to do, we should have to extend, same as a plane mirror, we have to extend backwards or forwards, then we can get the image formation. Yes, that type of image we are calling virtual image. The image is forming by the extended reflected rays, we are calling virtual image, and the image is forming by the real reflected rays, we can call real image. Yes, simply the definition for the real and virtual image, which will be directly caught on the screen, and virtual image is directly, it will not caught on the screen. Okay, so let me tell you. So in the case of the convex mirror, and how to find out the remaining one problematic question I'll give you in the case of the convex mirror, and how can we predict the magnification also, and how can we know the characteristic of image also. Okay, we'll see. Suppose I'm giving one more problem to you. So we are keeping an object, in front of a convex mirror at 7 centimeters, not 7, at 5 centimeters distance. Okay, whose focal length, which means which mirror focal length will be, the mirror focal length will be, so not 5 centimeters, which means at the finite distance, am I right? focal length will be 4 centimeters. Am I right? At finite distance. So as you know, in the convex, there are only two cases. The object is there at finite and infinite. Yes or no? Focus, pole, center of curvature. Whether we have to keep an object at infinity distance, then the image will be forming at the parallel light rays will be passes parallel to principal axis. These light ray parallel beam of light will be passes to the mirror, and again this is the diverging mirror. So the reflected ray will be diverged like this. If you are extending the reflected ray backwards, it will be intersected the focus. So if the object is there at infinity distance, in the case of convex mirror, the image will be forming at the focus, smaller point. Next case, let me explain this one also to understanding purpose. Okay, pole, focus, center of curvature, and the object is there at the finite distance, which means known distance. Okay, so even though some parallel will become and it will be diverged, whenever diverging, if you are extending backwards, passes through the focus, and if one light ray passes through the optic center, pole, okay, pole, it will also be reflect from the pole with a making equal angle. Am I clear? So now we are extending this reflected ray. Why? Because these two reflected rays are diverging now. So one is going like this, one is going like this. So those may not intersect anywhere because diverging. So we are extending backwards. Here the image is forming. Am I clear? Where the image is forming between F and P. So in the case of convex mirror, the image will not form behind F. It is always formed from F to P, in between only. Which means whenever the image is forming between F to P, compulsory the images are smaller, not larger, not bigger than the object. Am I clear? However, the bigger image it is, compulsory the image is smaller one only, either point size or smaller than the object. That's it. Okay. So we'll see. So this related, this is for in a convex mirror na. In a convex mirror na. So I am keeping an object at 5 centimeters, which means in a finite distance. Maybe this case will be possible. In this case, if you see, the incident ray direction is this side. The object distance we should have to measure opposite to incident ray. Am I right? So U will be negative. And image is forming in the same direction of incident ray. So V is positive. Yes? And F is also in the same direction of incident ray. This is also positive. Am I clear? So in the case of convex mirror, U only negative, remaining all are positive. Am I clear? And R is also positive. But in the case of the concave mirror, U, F, R all are negative. Okay, V is also negative from case 1 to 5, which I already explained in the previous case. And V is positive only in the last case, whenever it is forming a virtual image. Whenever it is forming virtual image, compulsory that will be positive value only, because it will form in the same direction of incident ray. That thing you have to remember. So let us see whether it will be satisfy this one. By diagrammatically we are getting this kind of, if we are analyzing the diagram, we are getting these values. We'll see, we are having U, F, and we'll see whether V is positive. For us, V positive, actually by looking at the diagram. We'll see whether we will be get V value positive or negative in the calculation. Okay, and based on smaller size we are getting here. So in the magnification also, compulsory magnification should be, we have to get less than 1. Am I right? And magnification, it is a virtual image now, magnification should be positive. We'll see whether all those will be satisfied or not. Am I clear? So now see, actually this is a case, so I am erasing that off one. So now apply sign conventions. Minus 5 centimeters. This is a convex mirror na. Convex mirror I said you. So focal length will be in the same direction of incident ray. So focal length will be positive only. Am I clear? It will be positive. So then we have to find out the image distance. 1 by F is equal to 1 by V plus 1 by U. So 1 by F is 1 by 4. 1 by V we don't know. Plus 1 by minus 5. So now if we see 1 by 4. I am taking this minus 1 by 5 minus 1 by 5 this side. It will become plus 1 by 5. If it is minus here or here, there is no change now. Minus into plus minus only now. So now 1 by b. So what is the LCM? 20. Okay. 20 means 5 plus 4. Okay. 4 5 are 20. 5 4 are 20. 1 by b. So 9 by 20. We need v value only now. So see, we are getting positive v only. It is satisfied if the v is positive in the same direction of incident ray it is forming. So now v value we need. So 20 by 9. 9 2s are 18. Again 9 2s are, which means 2.2 centimeters. Am I right? Positive 2.2. And what is the focal length here? 4 centimeters. But image is forming where? 2.2, which means focal length pole in between. Am I right? Yes, it is forming between pole to focus. It is satisfied now, and that to be positive. We are not getting negative here. See? So we are getting V positive means, I already said you, if it is a virtual image, compulsory the image distance will be positive. Okay? And we'll see whether it will be satisfied the condition. We are getting clarity. The image is forming between pole to focus in between. Why? Because focal length is only 4 centimeter is there. Even image distance is 2.2. So in between only forming. So one is satisfied. So and that to be positive only. In the same direction of incident ray, we are measuring the image distance satisfied. So now we'll see the magnification. Magnification is minus V by U. What is minus V? Simply I am writing 20 by 9 also I can write. Okay now? Minus of 20 by 9 by, what is U? Minus 5. Minus will be cancelled now. M is equal to 20 by 9 into 5 by 1 means 1 by 5. 5 ones are 5 fours are. M is equal to 4 by 9. So now in the 4 table 9 will not come. Sorry, in the 9 table 4 will not come. So 4.0 point. Okay, 4s are 36. It will be, sorry, and it will be 36. 9 4s are 36. Again in 4s. So which means M is equal to 0.4. 0.4 is a less than 1 or greater than 1? Of course it is a less than 1. So I said you in the previous video, so if the magnification is less than 1, compulsory which will be smaller than the object. Am I right? So if it is equal to 1, same size. If it is less than 1, smaller than the object. Is a smaller image only now? Yes. Am I right? Smaller image only. And what about the magnification is positive or negative? Positive. So when the magnification is positive, compulsory it is a virtual. Here virtual image only forming na virtual image. So if you know the formulas and if you know the calculation, whether you forgetting the image formation also okay, but if you remembering the image formation, you can you will get the value clearly. Okay, you may not confuse anywhere. Okay, that is a virtual image and direct image. Am I right? Okay. So once you can please check this problem, then you will understand. Okay, fine. So now see. So in the case of the convex mirror, so let me write a short notes like same like last time. In the case of the convex mirror, U is always negative. U is always negative because we are measuring the U value in opposite direction to the incident ray, right? It is always negative. And focal length always positive, because focal length we are measuring in the same direction of incident ray. Radius of curvature is also always positive. When you are solving the problem, if it is convex mirror, you don't need to apply sign convention for F and R, because that will be positive only. If you can also if you can also apply sign convention, it will be get positive only, because in the case of the convex, na, positive only in the same direction of incident ray. And V is also in the same direction of incident ray, so positive. So wherever the V is positive, magnification also we are getting positive. Wherever V is negative, magnification on we are getting negative. If you observe, that is the reason. If image distance is positive, then the image is a virtual and also magnification is a less than. Okay. But in the case of the concave mirror, V will be positive, because one case it will be virtual, right? It will be virtual in one case. But that is a magnification we are getting, which is positive only we are getting in the case of the concave, but which will be greater than 1 we are getting, which means that is a virtual image only in the case of the concave, but larger size. But convex mirror will always forms virtual image smaller size. Remember, concave, convex, what is the difference means? Concave is always forming the images behind F, means more than larger images will be formed concave. Convex will always form smaller images or point size images. Am I clear? So the convex is always form virtual. Sometimes the question also they will ask you. So in below the following mirrors, which always forms a virtual image and virtual and magnified image. Here always virtual means here virtual only actually, but not always magnified. Am I right? So virtual and magnified means compulsory you have to go for concave. Am I clear? But if they are asking question, which type of image will be formed always virtual image, means you have to go for convex. But that virtual is always magnified means you have to go for concave. Am I clear? Virtual is bigger image formed by a concave. Virtual smaller formed by a convex. Am I clear? And based on this, so we are using this convex mirror as a rear view, which I already explained to you in the application of part 2 video only. So rear view we are using because all the it is for if you are taking field view for the convex mirror also, it has a more field view. It can also cover the all objects. Suppose one vehicle is coming from this side, it can be form an image, that to be smaller image. Many number of vehicles it can be form as a smaller point size images. Am I clear? But if you are taking the convex, it may not form like that. It will be form a bigger size images. Am I clear? Okay, that is the thing. So now I hope you understand this video. I hope you like this video, and please thank you for watching the video. And if you have any kind of doubts in the problems and related to the problem related to the lesson which I have took, you just have to comment below, and please keep watching the video until that time, and we'll see you in the next video. And I hope this will be useful to you, and which is also useful for your friends, because many are getting feeling conflict about this type of problematic question to solve. Yes, before applying sign convention, how to do and what is the magnification, how to get all the things, they will be feel like a complicated. Yes. So now I just want to make you easy this process, and I want to make you to understand easily. That's the reason. This is only my intention, to make you easily, to make you understand easily. That is only thing. So please share this video to your friends, which is useful to them also. And also thank you for watching. Thank you for watching the video, and subscribe the channel and click the bell icon. Thank you. Thank you for watching the video.